All right, so that was ping and a little bit of ARP there. Let's also look at DNS, which I did mention we'd look at. All right, so if I do this, if I do a ping for google.com, and before I start that, I'm going to start a different capture here. So start a new live capture, continue without saving. All right, so that's ready to go. Go over here and hit enter. Looks like it's going to lose one, maybe two. There we go. All right, so one went missing. That'll actually be interesting for us to look at too. All right, stop our capture. So in this case, since we didn't know where Google was, we sent a DNS request out. So from us to our DNS server went out. It's a standard query. It's an A record, which is where the name of a device would go. So google.com, and then we got a response back for that A record saying that 72.14.207.99 is one of those records, and there's also two other A name records as well under the name of google.com. If we again break this thing out, I'm going to give a little more room here, break this out and look at it, the Ethernet packet, source and destination, notice the destination is our router. So we're sending a message to our default gateway to get off of our network, since we're going to 10.1.1. something network. So since we're going here, our Ethernet frame, our layer 2 frame, is going to our default gateway. From there, our IP packet, source, I'm actually highlighting the wrong packet here. There we go. The source is coming from us, now going to the destination. There we go. So now in this case, the source is going from us to our destination of the DNS server. So the DNS server information down here, protocol is UDP. All the other information as far as our IP addresses are in there. Go ahead and close that. Take a look at the UDP packet. The source is a random number, and the destination is domain of 53, which is the well-known port number for DNS. And then there was a query, so we're looking at the actual data portion of this. In this case, it's a standard query, and we're looking specifically for google.com as an A record. Okay, so that was our outbound query. The response, and this again is why you don't do DNS from a client perspective, using TCP as opposed to UDP. And think about what would happen for TCP if this was a request for Google. I'd have to do a 3-step handshake to go talk to the DNS server. So a SYN, SYNAC, and then ACK, just for TCP to set up the session. And then a query, this would be this message here, I'd like the name for Google. I have the name for Google. I want the IP address for Google. Then we get a response. Here's the response back, and here's the IP addresses for Google that you can use. And then we'd have a 4-step teardown for TCP just to shut down that session. Seems like a lot of work. I mean, if I had multiple DNS servers, or heck, even one DNS server that was really busy, I could send it 7, 8 requests via UDP, and if one of them responded, I'd be sending roughly the same amount of messages. So it makes a lot more sense for the client side to use UDP for DNS lookup. But I did mention that if a DNS server was transporting the database, the name record database, from one DNS server to another DNS server, then that certainly would have to be done using TCP. All right, so anyways, here's the response back. We got the response. Essentially, notice everything has been flipped. This message is coming from our default gateway going to us. It's then coming from the Ethernet perspective, and then from the IP protocol, it's coming from the DNS server going to us, crossing the whole network. It's UDP. It's flipped the source destination ports. Again, key to understand. And then the DNS response coming out basically says that the query was Google, and the answer was that for Google, you can use these 3 names, these 3 IP addresses to get there. So there was our response back. Now, what's really interesting is some of the DNS stuff. Depending on where you are in the world, you may get a completely different address. In the case of Google, if our lab here just so happened to be in Germany, what would happen is when we went out to our DNS server, it would respond back for a Google request for google.com. Has actually been told, and part of the DNS can do a localized search based on the DNS record, would respond back for the IP addresses for google.de for the German version of Google's page. So I actually like using Google as an example here because it gives me the ability to talk about some of the DNS tricks that can be used there. All right.